In 2020, 5 units at Wright-Patterson Air Force Base transferred to the newly created Space Force. The Air Force's 18th Intelligence Squadron transferred as the U.S. Space Force's 73rd Intelligence, Surveillance, and Reconnaissance Squadron, and it is one of the first ISR squadrons to support space operations and acquisition. The U.S. Space Force's National Space Intelligence Center is also being stood up here and will be the nation's center of excellence for intelligence of foreign space and counter space capabilities and intent. Now, let's hear how artificial intelligence is transforming the Air Force.
Good afternoon, everybody. I feel like I should take a page out of Chuck's introduction and everybody stand up, but I know we're close to happy hour and we have a fantastic final speaker for today. Thank you for that panel and for all the panelists and speakers so far. Well, good afternoon. My name is Sam Morgan. I'm a senior manager here in Dayton, Ohio with Accenture, and I lead our growth and strategy across our Air Force business. Many of you may have heard of Accenture. We're a large global consulting firm, and Accenture Federal Services, of which I'm a part, is a wholly owned subsidiary of Accenture with about 10,000 employees dedicated to U.S. federal government. We work here at DoD, Air Force, and across federal government, and the work we do encompasses a lot of things, everything from implementation of enterprise business systems to building and managing operational technology SOCs, or security operations centers, modernizing business practices on digital platforms, to engineering automated data pipelines. And everything we do, all the work we do, has the user at the center. Well, we put human-centered design principles into most of the work we do. Much of the work we do also focuses on innovation and what can you do with technology? How far can you push it to solve problems for the mission? And that's something that is not unfamiliar to our next speaker, Dr. Stephen Rogers. As the senior scientist for autonomy at the Air Force Research Laboratory, Dr. Rogers leads the autonomy capability team in the rapid advancement of autonomy research and development. He also leads multi-directorate coordinated autonomy R&D efforts, including the Autonomy in Motion and Autonomy at Rest portfolios. Dr. Rogers retired from the Air Force after 20 years active duty service, beginning his Air Force career as an enlisted flight line logistics specialist. He was later commissioned through the Airman Education and Commissioning Program and was assigned as a research engineer, developing a new high-order programming language. Following the completion of his advanced degrees, he served as a professor at the Air Force Institute of Technology for more than a decade. While at AFIT, he directed research efforts in areas that included identification of targets in a variety of sensors. After retiring from the Air Force, Dr. Rogers founded a company for developing practical applications of advanced information processing techniques for medical products. In fact, his company invented the world's most accurate computer-aided system for detecting breast cancer. He has over 150 technical publications and more than 20 patents. It is my distinct pleasure to introduce to you this afternoon Dr. Stephen Rogers. Sir.
So our mission together is I've got about 25 minutes to make you all experts in AI. Okay? I've been doing this for about 45 years, so it shouldn't take that long. The challenge is I was asked to look at, what are the implications for AI for Industry 4.0 and 5.0. And as I looked at that, it became obvious to me that you can't get to where you're hoping to get to. In fact, I can't get to where I'm hoping to get to unless we have some major breakthroughs in AI. So my job is to explain to you where we are and where we're headed and how together we might achieve what you're after and what I'm after. And I need you to not just think of Industry 4.0 as IIoT, not just the industrial Internet of Things, but the intelligent industrial Internet of Things, I3OT. That's sort of the mental image I want you to take with you. And I've been looking at this for the last couple of years, it turns out, under completely different auspices. I got this slide from one of my former PhD students, Tom Burns, who at the time was up at DARPA as the director of STOW. And together we were developing this idea called mosaic warfare. So the question we were asking is, how do we get away from that left side, these big monolith, single-purpose capability solutions, into a disaggregated set of possibly attritable assets. And as we looked at that, we came up with 3 key technical challenges. And I'm telling you, they're the exact technical challenges you're going to face in 4.0 and 5.0. They are, number one, and I heard the data panel just talking about this, is all the pieces of the puzzle have to be interoperable. And I heard somebody say, and I was ready to stand up and cheer, but I didn't want to interrupt them, it isn't via standards, at least the way we currently do standards. If you make the pieces intelligent, you have a shot at things learning how to work together. So I want you to think about interoperability as your first key technical challenge. The second key technical challenge is have systems that can compose together. They need to learn how to work together flexibly. Sometimes they work as peers, sometimes as supervisor tasking other agents, sometimes as subordinates. So this idea of things being able to compose together to do things they can't do individually is a key technical challenge. And then the third key technical challenge is adaptability. Each of these little intelligent systems, as part of your industrial process, need to learn how to change what they're doing and how they're doing it, quite often on the fly under their own auspices. Those are really, really difficult to do. But as you think about adaptability and you start thinking about being able to do multiple things, you immediately start thinking, oh, I want a system that's intelligent. Well, the first thing I did when the Air Force asked me to be the principal scientific authority in this AI and autonomy space was I convened a meeting, virtual meeting, of all the principals, all the stakeholders. And what I found is we couldn't have a conversation. Everybody was throwing around what Marvin Minsky used to call suitcase terms. What is intelligence? What is reasoning? What is thinking? What is understanding? And the problem we had is nobody could reliably say, so that everybody else would understand, what we could do, what we needed to be able to do, and put it into the same sort of jargon. So the first thing we did is we actually sat down and wrote a set of definitions. It wasn't to argue about this is the right definition or wrong definition, but unless we have that common baseline, we can't have a discussion. So if you want to see our definitions on the bottom of this, you can go out and Google Autonomous Horizons Volume 2, The Way Forward. In one of the appendices, we actually define all these terms. If I'm going to talk to you about the technical challenges in 4.0, I need to use some of these terms, so I have to baseline them for you. So in that document, the way I defined intelligence is the ability of a system to take observations and create knowledge, and then store that knowledge in a way that it can reliably later use it when it's relevant. Pretty simple definition, but it turns out to be extremely powerful. And then today an AI, an artificial intelligence, would just be computers that can do that. Go out and take observations, create knowledge. It's all about knowledge, knowledge, knowledge. It's all about knowledge, okay? Knowledge is what the agent is going to be using to take the observations and create meaning. The meaning will tell the system what's going on in the world and possibly what action to take. So if you can create the right knowledge to be able to create useful meaning, you're home free. So if it's knowledge, where does knowledge come from? In the history of the earth, knowledge has only come from 1 to 3 sources. Either you were endowed with it at your creation, at your birth, through your DNA, your genetics, by evolution, or you're complicated enough that you're allowed to go out and interact with the environment, and thus you have experiences, and you've been endowed with the ability to take those experiences, figuring out knowledge from them, and store it away and be able to get it later. So you get extra knowledge after your birth by interacting. Or third, if you're complicated enough to be able to communicate with other agents, it could be that they could tell you about an experience they had, and therefore you get knowledge without having to undergo the experience. Those have been always, the only way nature's ever figured out how to create knowledge is those 3 things. And as you go from left to right on this chart, each one is an order of magnitude faster than the one to its left. In other words, experience is an order of magnitude faster than evolution, culture is an order of magnitude faster than experience. We've followed the same path in machine intelligence, in creating knowledge in machines. We started out by fueling machines. In the 60s, when I first got into this business, we started coding up machines with all of the knowledge that whatever's going to use in the machine itself. It's sort of evolution. But recently, it started about in the mid-80s, we started letting machines interact with the world, a la the data panel, have it figure out the knowledge itself, experience. And we've had this explosion. We're going to talk a little about that explosion, okay? One of the things that explosion resulted in, this is a fact of life, and the data panel just drove it home. From this point forward on the earth, most of the knowledge will be created by machines, by the machines having experiences and capturing their knowledge. That's the upside. The downside is most of the knowledge being created by machines are only useful for that machine doing that task. Unless we solve the problem of how to make that knowledge more usable for a wider range of tasks, we're in trouble. And this is, you guys should be privileged. First time I've done this slide this way, where you're headed in 5.0 is going to be even a step beyond that. And that is what I'm going to call machine culture. In other words, once I crack that nut of being able to have these machines share knowledge and being able to have them use it in their own ways, that human-machine teaming and machine-to-machine culture is going to create even more knowledge faster. And so as you look at this is the world we're living in and where we're headed with what you guys are after. So as I think about that, and it's all about how do I get to those things on the right side and make them usable, I need to now do my task and explain to you where we are in terms of making machines intelligent, okay? So you need a history lesson. Well, luckily, if you're going to get a history lesson, you get an old person like me who lived through this history, okay? In the first wave of AI, when I first got into this business, it was all about, and it probably still is about, our own personal arrogance. We assumed we knew how we did things. And all I had to do was to talk to an expert and then code up what they told me. And we spent a lot of time, I can't explain to you the midnight hours I burned writing Lisp code to actually code into tens of thousands of lines of code, algorithms which codified what a human told me through this knowledge engineering elicitation process. Those first wave AI systems are very powerful, and they're still around. I'm going to give you some examples that they're still around. We still use that approach. But it's all about human-created knowledge, handcrafted and put into your machines, okay? Then in the 80s, we had this revolution, where instead of these complicated algorithms, which we got by talking to humans, we got from the data the algorithms. The algorithms we use in this second wave are trivial algorithms. They're virtually identical to the ones I wrote in a textbook in the 1980s when I was a young captain. I wrote a textbook on how to do machine learning, okay? The algorithms I'm using today, that my people are using today for the United States Air Force, are still stochastic gradient descent. They're exactly what we used in the 80s. But I have a lot more data, I have a lot more compute, and I can do things at a much bigger scale. The result is I have a phone that recognizes what I'm saying. It can recognize pictures, okay? That's all a function of second wave. We're still in the second wave. But we are fundamentally banging our head against some challenges the first and second wave doesn't know how to solve. And so this slide came from a colleague up at DARPA I2O, John Launchberry, when he was the director of I2O. He's now back at Galois. He sort of uses this to sort of teach the DoD where we are. And we all are looking towards this third wave, because we see some fundamental problems. So for example, in the first wave, I had brittleness associated with humans not being able to tell me all the facts necessary for a particular piece of knowledge that they had. They're not intentionally misleading me, but sometimes you just can't articulate all the pieces that went into your decision. And so there's some brittleness there. Sometimes my perception of the world feeding into the first wave is not correct. There's some brittleness there. The second wave has brittleness because of the handcrafted data. If in fact I give you a problem that wasn't in the data, it fails, and there's no way for you to know that, okay? It's a very difficult problem. So there's this brittleness in the handcrafted data in the second wave, brittleness in the first wave with respect to these rules, and so I've got to overcome that in the third wave. Now, nobody really understands third wave yet, what all it's going to consist of. We're making some great advances, but it's going to have to be able to handle the unexpected query, the thing that wasn't in my data. It's going to have to be that human-machine culture sort of solution. You have to be able to align these multiple representations. Okay, let's drive this home even more, because this is the key to you being able to walk out of here and actually use AI. You will know what to do, what is your next step. So I need to drive home to you so you understand what you would do tomorrow. So in the first wave, first I want to pull back and say the wave metaphor that John used in his slide is a little misleading. It isn't the first wave came and then went back out. It's still here. And so this is my favorite example of that. This is the DARPA Cyber Grand Challenge we did a couple of years back. And all of the performers that survived this competition were first wave. They were all implemented with symbolics, et cetera. Very powerful systems. To give you a feel for how complex first wave can be, you take all these computer systems with these different colors. Okay, they're each little cyber enclaves, little networks. Now their mission is to capture the flag against all the other networks. So gold is sitting there. It is a system unto itself. It goes out and surveys the environment and finds this other enclave, blue. And it not only finds blue, so it did the surveillance, it figures out that blue has a particular cyber vulnerability. And then it goes, finds an exploit it can launch to exploit blue's vulnerability, gets into blue, and then controls the exploit to exfiltrate information to capture the flag and get it back into gold. All done autonomously, no humans involved. All done with first wave AI. Pretty freaking cool. But as cool as that is, then you have Pink sitting there watching the network and sees what gold did. And not only does it see it, it understands it to the point of realizing that Pink has the same vulnerability that blue had, and so it immediately goes, patches itself so it doesn't have that vulnerability. Again, all with first wave AI. So what I'm trying to tell you is, a lot of people just disregard first wave AI saying it's came and it's gone. Not true at all. We are getting great mileage in lots of domains using first wave. The key is human handcrafted knowledge, and we'll return to that in a minute with respect to Industry 4.0. Now, second wave, the best example everybody loves to give, is this idea of image classification. You go to Google and you say, here's an image, what is it? How does that work? Where did that magic come from? It works this way. This is second wave, all from the data. So it turns out I put into this system, instead of human handcrafted knowledge, which is, hey, if I want to tell the difference between a Pomeranian and a Samoyed and a golden retriever and a bicycle and an airplane, instead of using handcrafted knowledge of looking for wings or feathers or fur or color or size, I'm just going to give you images and tell you what they are. Take this image and call it a Pomeranian. Take this image and call it a bicycle. Take this image and call it an airplane. You do that with enough data, and you have enough variables, parameters that it can learn using the trivial stochastic gradient descent algorithms, it will find the transformation from that raw data to that output category. So I've handcrafted the data. I have lots of data that I have examples from, and it will learn the features. It does what we call representational learning. In this area, humans are very poor at giving you how to disambiguate all the different types of images, because the types of cues are very subtle. It's not just size, it's not just color of hair, ... So it turns out when I try to do first wave and problems like this, I was running up against walls. You do second wave, it outperforms all the first wave stuff and gets close to human level performance. Pretty freaking cool, okay? So that's second wave, all right? Now, what does that mean to Industry 4.0? The way you need to think about it is, take this blue box as one part of your industrial process. It doesn't have to be a robot like I drew there. It could be your office, which does the ordering of parts, which are going into your ecosystem, okay? It gets inputs from the outside world, sensory measurements, and it needs to take those measurements, those observations, use the knowledge that's inside of it to create meaning, to figure out what to do. Hey, order more of this part versus that part, okay? That's the sort of challenge you're trying to do. It could be a piece of motor, it could actually be a robot, but it doesn't have to be. Any part of your industrial processes, look at it this way. It's got observations and it's got effectors. So how do I use first wave technology? Well, I already told you. Let's say, for example, I was monitoring my supply chain and I wanted to know when to order what parts. Well, I have some expert in my process. I go to Yvonne and I say, Yvonne, what are the rules you would use when, in fact, this is the situation of how many of these spares I have on hand and how fast we're creating products. And using her intelligence, she says, you take that, and that means you need to order so many of these and so many of those. I code those into maybe a lookup table or maybe a rule base, and that's how I solve it. Human-crafted knowledge coded into algorithms which process observations and then affect the actions, okay? In the second wave for Industry 4.0, it could be, what you really want to look for are those applications where the indicators are really subtle. So a great area we've used this a lot is in monitoring things like vibration measurements on a Black Hawk helicopter's motor. You know, by looking at the vibration measurements, even the experts can't tell when this system's about to break. But it turns out these second wave systems are very good at finding those little subtle variations which tell that this system is about to break, you better take it in for maintenance, okay? That's how you feed these sort of solutions. I get a bunch of examples of vibration measurements, and I know whether they went in for maintenance or not. I know how long they were down, and I use it. I use it to train it up. It finds the representation. It does the representation learning to solve that problem. Why are you going to go through all this trouble? because you want to avoid the problem, which this is a chart I got from a colleague at IBM, Jeff Jonas. You want to avoid this problem of enterprise amnesia. If there's information in your ecosystem that you should be using to make a decision, whether that decision is what to do or what's going on in your environment, and you don't use it, it's like you never knew it. It's like you forgot it. It's like you're amnesic associated with it. As you guys instrument more and more of your processes, you're going to have more and more connectivity, the vertical axes, and so the available knowledge is going up extremely fast. And if you're not exploiting it, you got an enormous gap between what you could be using and what you are using. That's the downside. Now, here's even a worse downside. Using the best AI I have, and I've got a team that is world class. I mean, my team took on Google and Facebook and all the big universities in several international competitions, and we beat them, okay? I've got a world class AI team. Even our approach to this sense making, to figuring out the so what in the data, we can't keep up with all the data that we have available that we should be using in this Air Force and the Space Force. There's this enormous gap, and there's lots of reasons for that. Part of the reason is the current AI solutions I'm creating are very narrow. They solve one problem, and I already told you, if I use first wave and my limiting factor is all those experts that I have to extract the knowledge, and it's brittle anyway. If I use second wave, I got to create all this data and all the labels. So I currently cannot keep up with all the opportunities we are facing. That is a challenge. And even if I could, even with those narrow solutions, I quite often fail because my current approaches to translating human articulated goals into mathematics, where I can use, for example, second wave, is limiting. My favorite example of that, this was given to me by a buddy of mine out of Google, Peter Norvig, and it's a great way to drive home to you that if I teach these systems to recognize things like, I'm going to teach it to throw out the dirty bathwater. Okay, it learns how to do that. The problem is it ends up throwing out the baby, okay? Now, if it's a grandson, it's okay, but don't do that to your granddaughters. They're important, okay? So we do not have a good way to articulate objective functions in a way not only to do what we want it to do, but to not do the things we don't want it to do. That is an unsolved problem. So I can't keep up, but even when I am keeping up for particular applications, I'm running behind with respect to the sort of robustness I would care about. Given all those problems, we're still finding great value in the AI that we're building. This is our way to look at that space. If you're going to go apply AI to your space, there's 4 things you have to get perfect. And I've done this for 45 years now. I'm telling you, these things always come back. If you don't get these all nailed, you lose. People, algorithms, data, and compute. You got to get them all right. You can't miss any of them. People is not just the people who are developing the algorithms, it's the people who are going to be touching them on a daily basis. We never field AI without doing what we call user-producer innovation. We have our producers of AI sit with the people who are going to be using it on a daily basis, and they together co-create a solution. We field solutions very quickly, and then we iterate as fast as we can. Minimum viable products into the hands of users are invaluable to define where you want your end state to be. Okay, so don't forget the users. It's not just them, it's the users and producers together. And then with respect to algorithms, this is a space where luckily we've got the Air Force and the Space Force convinced our old breaking out of the colors of money, where you do basic research and then you throw it over the fence and figure out what to do with it. We can't do that in AI. We are moving too fast. So we actually are mixing together this idea of fundamental research and fielding capability so we don't fall behind. All right, we are working with some of the world's best. I mean, they're on the bottom people we're working with. You can see some of the pictures there. They're the best at MIT and Carnegie Mellon, et cetera. Given that, then you've got the data, which you guys just had a panel on, so I won't stop there. And it was also mentioned in the previous panel, I've got several different computing needs, whether it's on the edge computing, on top of my drones, or in business IT systems where I have to get the authority to operate. I've got big compute challenges. I have HPCs I've been using. Anyway, once I get that fixed, then I use my platform to try to solve a problem. The challenges I'm facing that platform are exactly the ones I mentioned to you at the beginning as the tech challenges for mosaic warfare in Industry 4.0 and 5.0. Those flexibilities directly align. And then I'm using that technology platform to attack our 3 big strategic goals in AI, our mission effects, multi-domain ISR, and business processes. And when I first started talking to people about us doing business processes from AFRL, nobody had any interest. But I'm telling you, probably the biggest impact I'm having is in that space. I mean, we are fundamentally changing how the Air Force and Space Force hire civilians. We're fundamentally changing how we respond to Freedom of Information Act requests, how we ensure that we're not being ripped off in parts and labor pricing. Those are great applications where I'm changing the value equation for the Department of Defense. And with respect to ISR and mission effects, I'm really glad we're meeting today. News hot off the press. As we're speaking, part of my team is out at Edwards flying Air Force jets with our AI bots, controlling them, doing mission-related tasks. It's frickin' pretty cool time to be in this space. All right, given that, now what am I telling you you've got to do? How do you do this? How are you going to take this into your particular ecosystem? There's 5 steps. This is my empowerment slide. If you do these 5 things, you'll get out in front of your vertical. And you've got to do them in a methodical way. You got to pick some pilot projects. You need an organic team. You cannot get yourself the head on with your competition by going and buying your AI. You need organic capability. It was a hard fight for me to convince the Air Force of that, but you've got to have an organic team. You've got to educate everybody, and that starts in the C-suite. If you can imagine them putting me in my jeans and my Vibrams in front of a bunch of 4-star generals, I had every 4-star general in the Air Force for an afternoon at Joint Base Andrews, looking at me and explaining to them for 4 hours, here are the implications for AI in your mission space. And they listened. You've got to get in front of your C-suite and explain to them how this will fundamentally change the future of your companies. Okay? And then the 5th thing is, you've got to figure out this strategy. Now, a lot of people say, well, why don't you do the strategy first? Industry has figured out, if you do your strategy first before you get into the space, you will make mistakes. Get into the space with the right pilot projects, then return to your strategy, and not unlike your data standards, make it fluid. Make it where it can be updated. And then open up comms. That is, everybody in the organization should see what you're doing and how you're doing it, and then externally, what is this new capability you're bringing? I got 60 seconds left, and I want to get off the stage by why I was willing to do this talk today. The most important problem that I believe this country is facing is social inequalities. You guys don't think of yourselves as this, but you are the way out of that issue. Most people think AI is going to lead to massive unemployment. I'm telling you, I've been doing this for 45 years. It is going to be exactly the opposite. This provides you an enormous opportunity to hire those people who are not STEM graduates. You don't need programmers. You think you need programmers, you do. But I can write AI that can write code. What you don't have is that creativity in the minds of those people in the inner cities. You have a great opportunity to do pilot projects with the most impoverished, most at-risk people in our society and bring them into your organizations and bring value by teaming them with the right AI. If you do that correctly, you are the way out of this mess we are in as a society. We can change the income inequalities. We can lead to full, meaningful employment for everybody in this country if you do that right. And I encourage you to think about that. I encourage you to adopt a neighborhood. Avondale and Cincinnati is where I would start at. And look for people in that culture, that neighborhood, working for you as part of these human-machine team pieces of your ecosystem. I'm going to stop there.